Hello friends, today we are going to see the principle and the selection of Mechno electrical actuator, where we will see the different type of actuator where the input signal is a mechanical or the input signal is a electrical. In the same way, the output signal mechanical or can be electrical. So, principle and selection of Mechno electrical actuator is a simple thing is that the actuator where the input can be mechanical signals or can be electrical signals, but when we consider the mechanical signal as an input energy, then the output of an actuator, it can be an electrical signal. In the same way, if electrical signal is an input of this particular actuator, then the output of this actuator is mechanical energy. Let's start with some common example of Mechno electrical actuators. So first one is a DC motor, second is a stepper motors, solenoid valve, servo motors and BLDC. These are the various examples of Mechno electrical actuators. So let's start with the first type of Mechno electrical actuator, that is a DC motor. In this part, we will see what is DC motor, what are the various example of DC motor and what are the different types of DC motor. So first, what is a DC motor? It is a device that converts direct current into mechanical work, or it can be simply say that it's an electrical motor is an electrical machine which convert electrical energy into mechanical energy. So as I am saying earlier that actuator is particular system, it's a particular system, and here is in this type input is an electrical and the output is mechanical. Let's start with the elaboration of the DC motor with the principle of the DC motor. Now, it works on the principle of Lorentz law. What the Lorentz law says that whenever a current carrying conductor placed in a magnetic field, it experiences a mechanical force, and this force is called Lorentz force. So here is our conductor and it carrying a current, that is I, and when this conductor placed in a magnetic field, you can consider as a north and south pole. Here is our magnetic field. This conductor experience a force and this force is called Lorentz force. So in DC motor, this force is also called a mechanical force. So for the calculation of this force, we having another rules, that is a Fleming left-hand rule. So F is calculated by Fleming left-hand rule. The equation of the force is F is equal to BIL, where B is the magnetic flux of a density, I is a current which is flowing through the conductor, and L is the length of a conductor within the magnetic field. As you know, the simple part of the magnetic flux is it's when a conductor cuts magnetic field, it produces a magnetic flux, and depending upon which density the cuts the conductor to a magnetic field, a magnetic flux density is depend. So By calculating B, I and L, we easily know what is the value of force that can be experienced by this conductor. Now, here you can see here the different working of a DC motor, where south and north pole experience a magnetic field, and when current flowing through this battery in this direction and it is again coming this way, so the thumb indicates mechanical force, the middle finger indicates the direction of current, and the allied fingers indicate magnetic field. So here is middle finger indicates the direction of a current, that is in this way. Same way, a magnetic field indicated here, and the force is shown is in upward direction. This is a simple working of a DC motor. Now, before understanding the working of a DC motor, first we have to know their construction. So, what is in construction of a DC motor? You can consider it in a simple way, that is, it consists of one is a stator part, another is a rotor part. So simple, stator is a stationary part and rotor is an rotating part. Let's see in details. The armature and stator are two main parts of a DC motor. The armature is the rotating part and the stator, as I am saying earlier, that is a stationary part. The armature coil is connected to the DC supply. See here, armature coil is connected to the DC supply. Here you can see the pictorial view of actual DC motor, where this is a shaft which is connected to the rotary part, and here you can see a rotary part, and here is a frame of a motor which is a stationary part. Now, armature coil consists of commutators and brushes. So commutator, what is commutators? Commutators convert AC induced armature into DC, and brushes transfer the current from rotating part of a motor to the stationary part, which is external load. Though the armature is placed between north pole and south pole, the permanent magnet is also there. So the armature is placed in the magnetic field, and commutator converts AC induced in an armature. Now, when armature winding is connected to the DC supply, an electrical current set up in the winding, and magnetic field may be provided by the field winding, that is called electromechanism, and by using permanent magnet. So, field winding or by permanent magnet makes an important role to produce magnetic field. In this case, a current carrying armature, or you can say a current carrying conductor, experience a force due to the magnetic field. And according to the this is according to the principle as stated above, that is Fleming left hand rule. So here you can say easily south and north pole. Here is a brushes, and armature is connected with the power supply by brushes in between that. So when a current flowing through this armature, it experiences a force that is in upward direction. Now, the various type of DC motor. DC motor are usually classified based upon their excitation configuration. So, the configuration having two parts, one is the stator part and another is the rotor part. The rotor part is also called an armature. An armature, or also called as it is a field winding. Now, the field winding is fed by an external source. Depending upon the excitation configuration, DC motor are divided into two parts. One is separately excited DC motor, another is self-excited DC motor. So what is separately excited? It is the field winding and external source is being separated. In self-excited part, series winding and the shunt wound is also on two types of self-excited, where series wound is a field winding is connected in series with the armature. That is, if we consider is a field winding here, it is connected in series with the armature. This is series wound. But in the shunt wound, field winding is connected with the parallel of the armature. That is shunt wound. Again, third type of self-excited DC motor is in long and short shunt compound motor. So, depending upon the size of a shunt, compound motor divided two parts, that is a long and the short shunt DC motor. DC machine are usually classified on the basis of their field of excitation method. This makes a broad two categories of a DC machine. This is a DC machine, not a DC motor. So, the DC machine categorized in a separately excited and the self-excited. As I explained earlier, separately excited DC motor, DC machine, the field winding is supplied from the separated power. So, the supplied from separated power is a main thing in the excitation of DC motor, separately excited DC motor, and that means field winding is electrically separated from the armature circuit. Now, in self-excited DC machines, field winding and armature winding are interconnected in various ways to achieve wide range of performance. So, series machine is divided as series wound, shunt wound and the compound wound that I am already explained. Now, the compound wound DC machine is also a short shunt or it can be a long shunt. We will see the details of compound wound DC machine. That is, in this type there are two sets of field winding. One is connected in series and other is connected in parallel with the armature winding. So, when field winding is connected in parallel with only and only armature winding, that is called short shunt, and if field winding is connected in parallel with combination of a series field winding and the armature winding, that is called long shunt. So, as you know, the simple logically manner that if the field winding is connected with only armature winding, you require short shunt. But when field winding connected parallelly with the combination of series field and the armature winding, we require a long shunt. So the compound DC machine is a two type with the short shunt and the long shunt. Now here is the overview summary of a classification of DC machine. So we'll revise one by one. That is, a DC machine broadly categorized into separately excited and the self-excited DC motor. In the separately excited DC motor, armature winding with the field winding are divided into two parts, and that's why it is a separately excited DC machine. In self-excited DC machine, armature winding and the field winding connected in series, that's why series wound DC motors. When armature winding connected parallelly with the field winding, it is called shunt wound, and when armature winding connected in series with the field winding, it is called long shunt, and armature as well as field winding connected with the short shunt, it is called short shunt compound wound. So here we end our DC motor part. Now let's move to another Mechno electrical actuator, that is stepper motors. So let's start with what is the principle of stepper motor, what is the definition of stepper motor, and how it is worked. Now the stepper motor operates differently, completely different from the DC motor, but the phenomenon of working of a stepper motor is same as the DC motor. The DC motor rotates when voltage is applied to the terminals, but in the stepper motor, it effectively have multiple tooth electromagnets arranged around a central gear shape. As you see here, the central gear shape and the piece of iron, the electromagnets are energized by an external control circuit. This is, if we consider an external control circuit, the simple example is a microcontroller. And here is the pictorial view of a stator motor where different tooth of electromagnets is arranged. Now let's see detail about the working of stepper motor. To make motor shaft run, first one electromagnet is given power to gear teeth, which is magnetically attracted to the electromagnetic teeth. Now the point where gear teeth are thus aligned first with the electromagnet, they are slightly offset from the next electromagnet, that is slightly offset. Now when the next electromagnet is turned on and the first is turned off, then the gear rotates slightly aligned with the next one, and from there the process is being repeated. So from the first gear to the second gear, there is slightly aligned, and when one gear is on, one electromagnet is turned on, the another magnets, or you can say a gear teeth, is off. Each of those slight rotation is called step, and with this integer number of steps making a full rotation. Means what? Gear teeth and the electromagnets are aligned together. When we are applying an external supply to the electromagnets, it's gear up with electromagnets, and when it complete one cycle, that is when it is complete from one cycle, that is called one step, and depending upon how much steps is completed from one electromagnet, it is called stepper motor. So in another way, motor can be turned by precise way, and the stepper motor doesn't rotate continuously on the rotation steps. Means what? If we consider one particular small voltage as a pulse is applied to particular magnet. So when complete circle goes on end, then one step is completed. So in this way, how much pulse we are applying, as we are increasing the pulse, the steps is also increases, and that makes this type of motor is in precise way. So it does not rotate continuously, it rotates depending upon the pulse applied to the particular electromagnets. Now, the types of stepper motor: permanent magnet, hybrid synchronous, and the variable reluctance is a type of stepper motor. So permanent magnet stepper motor is a motor that uses a permanent magnet. That's why it is called permanent magnet stepper motor. In this, the rotor operate on the attraction or the repulsion between rotor and permanent magnet, and hence the stator of electromagnets makes an important role. So what is that? The attraction and the repulsion between rotor, that is the permanent magnet, it is in permanent magnet, and the stator of electromagnets. This makes a permanent magnet stepper motor working. Now, variable reluctance stepper motor, where a plain iron rotor and operates based on the principle of minimum reluctance, occurs with the minimum gap, and hence rotor points are attracted towards a stator magnet poles. So in variable reluctance stepper motor, minimum reluctance is occur, and here is the maximum attraction or the repulsion is been occurs. Hence rotor points are attracted towards the stator of magnet poles. So here is the attraction or the repulsion between two things is different. Now the hybrid synchronous stepper motor. In this hybrid stepper motor, namely because it is a combination of permanent magnet as well as variable reluctance. So in variable reluctance, we are seeing only attraction part, and in permanent magnets it can be attraction or the repulsion. So these techniques, so both combination techniques achieve the maximum power in a small package size. That is the advantage of a hybrid synchronous stepper motor. Now, here we end the stepper motor part. Let's move to the another type of mechano-electrical actuators, that is solenoid actuators. So, solenoid actuators is one of the most common used application-based mechano-electrical actuators. So, what is a solenoid actuator? It is converted electrical signal or electrical current into mechanical linear motion. So here is our actuators where input is electrical and it converted into mechanical. So mechanical can be linear motion or it can be angular motion. So it is made up of movable coil and iron coil. The pulling and pushing strength determine the number of turns of the coils. So when the output of actuator, it is in reverse direction or in forward direction, that is a depend upon the number of turns in the coil. Now here you can see the solenoid valve's cross-section pictorial view, where is a combination of two basic functions. First is a solenoid with the core and its component. Second is a valve body where there are plates, plugs positioned to the stop or the flow of the flow. So here is input and here is the output. Here is the coil and here is the spring present. So when solenoid liquid flowing through this way and it is goes on circling same way, and this is when the spring is actuated and this is when spring is not actuated. The flow can flow depending on the core movement and depending on whether the solenoid has flowed or not. So as you see here in this diagram, inlet the flow is there of a liquid, and here only inside the solenoid liquid is flowing only in the inside way, and that's why our core is in stationary position. If current flow, the coil will push the core to open the channel or the valve, and when it is not flowing, the channel will be closed. As you see here, channel become closed. The working principle of a solenoid valve is that inside the solenoid there is a coil that is circulated in a special way. When you send an electrical current through a wire, a magnetic field is created. See here, when you send an electrical current through the wire, here is through the wire. When electrical current is sent, then and then only a solenoid valve is actuated. The inner shaft of the solenoid is like a piston. This is our inner shaft. It acts like a piston of a cylinder made up of iron or steel. It is called a plunger. It is called a plunger or a slug. This is called a plunger or a slug, which is equivalent to a dynamo position. The magnetic field then applies strength to the plunger. Magnetic field is applying, see here, applying here, and either by pulling or pushing. So here is pulling downward direction, and when magnetic field turn off, the plunger return its original position. So here is make in downward direction, and here it become its original position. Now the types of solenoid actuator. It can be pneumatic solenoid valves or it can be hydraulic solenoid valves. As you seen in earlier slide, the inner medium of a solenoid valve can be liquid or it can be air. So depending upon the inner medium of a solenoid actuators, it can be pneumatic solenoid valves or the hydraulic solenoid valves. Now, what is a pneumatic solenoid valves? Here you can see the picture of a pneumatic solenoid valve. This is a rotation version of a solenoid where magnet stay outside and the coil part moves in the arc controlled by the flow of current through the coil. Now the rotary coil are widely used in the device such as disk drive is a switch for flowing air into pneumatic actuator devices, allowing relatively small signal to the control large devices, and also interface between electronic controller and the pneumatic systems. So it is an interface between electronic controller and the pneumatic system. Now hydraulic solenoid valves, as you know, in pneumatic solenoid valves, it is the version of solenoid, rotation version of a solenoid. Here it's generally similar to the pneumatic solenoid, where expect that it control the flow of hydraulic fluid, and that's why it is called hydraulic solenoid valves. Hydraulic machines are use solenoids to control the flow of oil. So here the medium flow of hydraulic is oil. So solenoids are often used in irrigation systems where relatively weak solenoids open and close small pilot valves, which is in turn activate the main valves by applying fluid pressure to the piston or diaphragm that is mechanically coupled with main valve. Here is the picture of a hydraulic solenoid valve where the cylinder is inside the presence, and here is the controlling part or the supply part. Typical application of a solenoid is in linear application. Valve actuators, latching, it can be used for the latching or the switching purposes. It can be used for the pushing or the pulling objects. It can be used for the sorting, shutter downs, and the fuel injection part. Generally, solenoids either linear or it can be rotary, and it is operated with the application of DC voltage, but they can be used with AC sinusoidal voltage also, and by using full wave bridge rectifier to rectify the supply, which can be used to switch the DC solenoids. Means what? Whatever the voltage supply are you apply to the solenoids, it can be DC or it can be AC, but generally we are using the DC power supply. But by using full wave bridge rectifier, we are also use an AC power supply. The small DC type of solenoids can easily control using the transistor or the MOSFET switches are ideally for the robotic application. So as you know, the application of a solenoid, it can be used for the pulling, pushing, linear motion or the angular motion or the oscillatory motion. These all the motion, whole motions are used in the robotic application. Here is one of the circuit diagram for the switching solenoid with using the transistor. This is our transistor which is used for the switching purpose. For the faster switching purpose, we can also use the MOSFET. Here we are applying square type input signal. So when it is in positive side, our switching transistor is on. That means when positive pulse is here and here is our negative pulse, in this time our switching transistor is on, and when negative pulse is applied to the transistor, our transistor become off. And that is all the switching purpose of this transistor is controlled by the flywheel diode, and that output is connected to the solenoid walls. Some form of electrical protection is required across the solenoid coil, and to prevent high back EMF voltage from the damaging of the semiconductor switching devices, this type of diode is used. For the protection purpose, we require a high back EMF voltage that is damaging from the semiconductor. In this case, a standard flywheel diode is used that could equally use as a Solenoid diode for the small value of resistor. See here, the flywheel diode is used when positive pulse is applied, and that can be used for the diode is flowing in forward bias, and hence flywheel diode makes an important role for the electrical protection purpose. In this way, we can conclude that there are various types of solenoid coil, solenoid actuators, electrical actuators. In electrical actuators, DC motors, stepper motors are the various examples, and here we can conclude that Mechno electrical actuators with having various application in not only in industry but as well as in home automation. Thank you.